All right. So, good morning, good afternoon, and good evening wherever you are. Welcome to this live stream on Android's Project Treble. My name is Kareem Yagmor, and in the next hour or so, we are going to delve into the intricacies of Treble and look at why this change was necessary, and what it means practically for people that are making devices. Now, in addition to those of you who are joining us over YouTube live streaming, I do have a live audience in front of me. I've invited a couple of folks to join using some kind of web conferencing tool so that I can have an audience in front of me. So I'm better when I teach to body language. So having faces and a live audience is going to make this more productive stream. Now, regardless of where questions are being sent to me, be it over the YouTube I have set up, I will repeat the questions that I get, and we'll take it from there. Now, the other thing I want to mention is that this is our first live stream over YouTube, and so we expect that we may have some kind of runtime adjustments to make. So if you see any sort of issues around or feel that there's any problem, try to let me know. There's a chat in YouTube, and the folks that are on the call with me that I can hear can call me out if they see anything blatant. So I'm going to go through about 60 or so slides. The slides will be available after the presentation, and if you watch this anytime in the future and you see any issues either with the slides or any of the parts of the presentations, then I'm happy to hear back from you, and I'm an eager learner, so if there's any issues we will eventually fix them. All right, so let me go ahead and get started right away. So as I said, the slides will be available after the presentation online, probably over SlideShare. Now, just to give you a bit of background about myself, so I wrote the Embedded Linux book for O'Reilly about 15, 20 years ago now. And a couple years back, I published the Embedded Android book with O'Reilly. I've been involved in open source for 20 some years now. And I'm most widely known in the open source community for having contributed the Linux Trace Toolkit, which was the first tracing tool for the Linux kernel. So, and if you go looking around the kernel sources, you should be able to grep for my name somewhere in there until they discover that whatever I wrote has bit rotted and it gets taken away. The most important thing that I usually remind people at this stage when I'm presenting my background is that I don't actually claim to know everything. Both Linux and Android are huge, and so there are things which are not, in my knowledge. And if there are any questions that I can't take, I'll try to direct you in the right direction. Otherwise, if you ask me something that I don't know, I'm happy to explore it and possibly come back to it at a later point, either through some kind of webcast like that, or a blog post, or some Google Plus post, or whatever else. I also realize that there are a lot of people joining in who will have far more experience with some of these aspects, or possibly have had more specific experiences in some regards. So if you have any kind of input that is useful to other people attending, then by all means, please go ahead and share it. I'm happy to take that as part of the presentation. Alrighty, so without further ado, what are we going to talk about? So a couple of weeks back, I had published a blog post series on a partner company's website regarding Treble. And so this presentation kind of is inspired by that. Obviously, there's a lot more to be said about Treble than what I can fit in 1 hour. However, tomorrow I am going to take one aspect and delve into it a lot more, specifically the Heinel capabilities or additions that have been made to have essentially Android be more portable or more backward portable, more specifically in the future. If you have any specific questions regarding to Heinel, probably tomorrow is going to be a more appropriate time to delve into that. Also, the presentation today is more slides oriented, although I may go back to the shell and show you some stuff. I'm using an emulator image here to demonstrate some stuff. But tomorrow is going to be more source code oriented. I'm going to be spending more time in the sources, showing you things around, and so on. All right. So, what is the goal of presentation? Release history of Android and so on. So, first off, I want to kind of present to you what are the overall goals of Treble. Why did Google kind of feel compelled to create this? I want to describe the differences between essentially Android's Treble and how things were done prior to that. Obviously detail what's inside Treble, and also, I guess most importantly, kind of outline the implications of this if you're building a custom product, and some recommendations as to what you should look out for in the future. Okay, so there have been quite a few releases of Android over the years, and if you've seen some of my previous presentations, I usually go down this list a bit quickly here and kind of summarize, the differences of you say release philosophies. Some versions being proprietary, others being open source. Most of them being open source, but Google, using Android as a basis for other things. Some of the things they release based on Android are not available actually in source form, at least not immediately. The one thing I want to highlight, given the topic today, which is Treble, is using this kind of history as just kind of a illustration. What I want to highlight is that most of the releases that we've got here have had additions which changed little to nothing to the actual underlying architecture of the operating system. So effectively, the additions were in the spirit of the same architecture that had been laid out since the early days of Android, give or take a few major things around, say for example SE Linux and SE Android. The release that had a substantial impact on the internals, however, is 8.x with the introduction of Treble. So that's kind of like a break from the past in terms of how things are found, or how new things have an impact in new releases of Android. So in terms of the previous documentation of previous knowledge that you might have of the internals, everything will apply just the same, except for when it comes to Treble and what that means. And so the reason I kind of went out of my way to try to find time to create this webcast or live stream is to allow people to catch up to those changes, especially knowing that a lot of people have been following my work in terms of the internals and such. So that's the major thing that we've got here in 8.x, as I said, which is Treble, which makes a big break, I should say, with how previous versions impacted developers all around. Now, if you're an app developer, Treble doesn't actually appear on the radar too much. It's a bit kind of invisible. If you're a platform developer, however, it changes everything, because the way things were done in the past need to be revised, sometimes in substantial ways. So just to recap here quickly for those of you who may not be familiar with Android's architecture, I'm going to really go quickly here because a lot of people have either familiar with this, or if you aren't, then you can just go look at some videos on YouTube of my past presentations where I actually take the time to walk through this more in depth. So so we got here essentially kind of three general layers. So we've got the kernel with the native layer, we've got the core of the framework, and then we've got the applications on top. And the color coding here goes a bit with the programming language and also kind of like the layers. So most of the low-level stuff is in C, the middle stuff is mostly in Java, and then the applications are also in Java, but they're regular applications, not part of the framework. Now, the way Android has been engineered in the past is that this layer here, the app developer layer, is the one that remained mostly constant. Everything underneath here essentially was subject to heavy changes, even across one version to the next, and possibly those changes could have been breaking in nature. So in other words, they might have changed the internals of a system service, the signature of a hardware abstraction layer module, the libraries being used, anything in here, anything went in terms of possible changes. Treble marks a difference with that philosophy in that there are some additions that have been made here to make the framework itself more easily upgradable. And I'll explain to you why those changes were made and what they actually entail in detail. Specifically, the changes that are being made are touch the lower parts of the stack here. So that's why, if you're an app developer, the changes might not be as visible or as impactful as they could be for people working on the platform. Okay, so just to understand, how things were done prior to Treble in terms of releases. So, and I'll have a diagram a bit later that shows this in a bit more detail. So, Google comes out with a new release. The ecosystem takes the stack I showed you, customizes it to developers, to their devices. And then essentially Google checks that the port works properly by running CTS, the compatibility test suite. And if it does, then the device gets certified and it gets to Google mobile services. And unfortunately, the trouble with that was that devices rarely got upgraded. I mean, that was kind of like the de facto thing out there. Maybe they got a version, or maybe two at best, but never too many versions. So why did Google change things, and so what is where does that take us? So if you look at and this is probably kind of like one of the most important slides in this entire presentation. And I don't mean to pick on Android. I love the thing. I've been working on this for years. So, but still, if you look at iOS versions versus Android versions. So right now, and these are stats that are coming from the respective companies. So this is coming from Apple, and that's coming from Google. So as it stands right now, the bulk of iOS devices are running iOS 11, which was released, I believe, last September. So that's almost like the latest. This is the latest version, and most of the rest are running the previous version, which is iOS 10. Now, if you contrast that to Android, okay. Right now, like the latest version, which is 8.0 or 8.1, they're like very tiny parts here of the pie chart. And if you look at the version that was before, which is 7.1 or 7.0, we've got, say, I don't know, 25 to 30% of the pie chart, and the rest of it, so almost 75% or close to, is running versions which are not even the previous version. So if you kind of compare this, that would be kind of like this part of the pie chart for Apple. So that's an issue. I mean, that's a really big issue for everybody, not just for Google as a company working on Android, but for people that use this operating system and people that develop products on this operating system, because Google puts a tremendous amount of effort of coming out with new features for Android on every release, and yet we're in a situation where the time it takes for consumers to get these versions or these enhancements is going to be a few years. Usually the time for them to obsolete the device they have in hand. because even though every party, as we'll see later in the phone manufacturing ecosystem, wishes that you replace your phone within 2 or 3 years, what actually happens is people hang on to those devices for a very long time. And for people that I work with a lot who are making custom devices, that's also an issue, because the path for upgradability for the devices they work on is not straightforward. Sometimes they get stuck on an old version for a variety of reasons, and the reasons are actually similar to those that are encountered in the phone ecosystem, and therefore Google, by solving this problem, is going to also help solve the problems that are encountered by people manufacturing custom devices, at least to some extent. So kind of like to show you what this means historically. So this is actually a diagram that I get from Wikipedia every so often. And unfortunately it's not been updated for a while, but it still gives us a good snapshot of how things go. So you can see here, like, a new version gets introduced, and you can see the amount of time it takes for that version to essentially kind of find its way into the market. And you can see that you can take any kind of slice of this and draw a pie chart like the one I showed you before, and you'll see that the versions being used are such that people always end up using older versions. So this is kind of what I mentioned before. We got cool features in Android, but the perception is iOS gets them first. So obviously this is kind of my reading of why Google is putting time on this. They don't necessarily go into that level of detail as to the logic behind their business decisions, but I think it's probably a fairly safe bet. Now, the official line from Google, if you go to source.android.com, this is kind of like the beginning phrase for the introduction to Treble. The 8.x release includes Project Treble, a major re-architecture of the Android OS framework designed to make it easier, faster, and less costly for manufacturers to upgrade devices to new versions of Android. And this really is important, because that kind of, in one phrase, they explain the entire problem. Mainly, updates are a problem, right? We know this, and anybody looking at the charts I just showed you before knows that as well. So why is that? Well, because it's difficult, it's long, and it costs a lot of money. So people don't actually do it, and that's what Treble tries to address. That's the root problem that we are trying to solve here with Treble. Now, how can Google solve the problem that we just spelled out, since they, this thing is open source? Well, anybody can download Android, customize it, do whatever they want with it, and ship devices, of course. The only thing Google can do is enforce certification with Google Mobile Services. It has no ability to force any upgrades. The only thing they can do is incentivize, and the real key to the entire ecosystem, as I had mentioned in other presentations that you can find around, is they control the use of the Android trademark. And in order to use that, along with having access to the Google Mobile Services, you need to essentially go through the certification process they have in place. And historically, this has been CTS. In the case of Treble, the way they've incentivized or enforcing this thing, and in some regards, it's it's far more stringent now. The way they're doing it is with this thing called VTS. So this again is a quote from them. So to ensure for compatibility of vendor implementations, the new vendor interface is validated by the vendor test suite, which is analogous to the compatibility test suite. All right. So in other words, they charted the path to the upgrade, but you have to comply or they won't certify, and that's important because that means that we're forever moving forward from 8.x into the future. Any device that aims to be certified as a real Android device will have to be upgradable, and for consumers, obviously, that's great. Obviously, for people that have to certify their devices, that's more work. But for people working on custom devices, such as a lot of people that we work with, essentially this also means that there's a path charted in terms of being able to upgrade your the custom devices that you ship to forward versions, and that's definitely a welcomed addition. Now, Okay, well, if you're a handset manufacturer and you try to say, well, this is not of interest to us, we want to be able to customize this thing at a greater level, we don't care about this VTS. Well, the problem is obviously that Android is pretty much the only game in town, apart from Apple. 85% plus of the market share of smartphones belongs to Android. So they've got a pretty strong hand in forcing people to actually do this. Maybe 10 years ago that would not have been as possible, as they were trying to kind of get a lot of people on board. Now, ultimately, it appears that the goal that they have set themselves is that they want to be able to do upgrades for 4 to 5 years, which is pretty cool. I mean, you can see the Apple Keynote every year with the Apple CEO going on the stage and saying, 70x% or whatever x% of people are running the latest version of iOS. Well, in 4 or 5 years, Google CEO will be able to do the exact same thing because of this Treble thing. All right, so let's take a look at the traditional release flow and see how Treble changes this. So historically, this is how an Android release would reach a consumer. So Google puts out a new release, and by the way, this diagram comes from one of the blog posts by Google under CC by SA or whatever. So the release is made by Google, and the silicon manufacturers, the major ones out there, be it Qualcomm, Intel, Freescale, whomever. They take that and they create a board support package, a BSP, all right? This BSP essentially, and usually this will go kind of like on the latest versions of their chips, because that's what they want to do. They want to sell chips, they want to sell the nice new things they have. Then the BSP will be taken by device manufacturers, so that's your Samsung, LG, Lenovo, or whatever else. And then they create a phone SKU. So this is actually a phone with their brand that runs that version of Android. Going from here, essentially, you've got the carriers taking this and then doing some more certification or just technical checking on the devices, and then the device actually goes to the end user. So that's how traditionally, essentially, the flow of things went for a new version of Android to be to be released to the public. Let me see here. I got a question on the chat. Let me just double check this. So, are you talking about Treble as implementation in Oreo or the final solution? So essentially, I'm talking here about Treble as implemented in Oreo. We will have to see in the end what it actually looks like. As I'll mention later, I actually think there are going to be some differences that have to be done. Okay, Sharbox, good to see you here. So non-certified devices can't get any Google apps anymore. They check and block. That is correct. As Sharbox mentions in the YouTube chat, you've got essentially now, and I believe this kind of made the news yesterday, if you have a non-official Google device that somehow had the Google apps copied to it, nowadays they'll actually block the device from actually connecting to the Google Cloud. That'll be interesting to see how that actually kind of evolves over time. Okay, so essentially, what we're talking about, if you kind of look at from a very simplified internals perspective, what we're talking about here is that the framework that they create has to be matched with a vendor implementation. And so this dark gray box that you see here, which says previous vendor implementation, that is the job of the silicon manufacturer and a device maker. To a lesser extent, I don't think carriers are involved in that, but mostly silicon manufacturer and device maker here are involved in this, previous implementation. All right. Now, if you move to a new version, Google comes out, changes the framework. Okay. And then essentially the framework glued to the vendor implementation changes, and then that requires essentially reworking that vendor implementation. So as you can probably foresee here, these people these parties are going to have to be involved again for this release to actually make it out, or this updated release to make it out to the consumer. All right. So if we take, say, an example, just to kind of like walk ourselves through the process of what this really meant. Let's say we had a phone from early 2014, okay? And I'm just using these companies for example. I could have used other company names, and I don't mean to pick on any of these manufacturers or companies, great companies for all I know. So let's say you bought a phone that was a Samsung device using the latest Qualcomm chipset from Verizon, and it's running 4.4 KitKat, all right, at the time you buy that device. There's no device specifically that I have in mind when I came up with this example. It's just really kind of prototypical. So let's say 5X comes out. So this is November 2014. In other words, a couple of months after you bought the device, a new release of Android comes out. What does it take for that release to make it to your actual device? So Google comes out with the 5X release. Then Qualcomm, looks at this and says, okay, are we still selling this chip? All right. There's no reason for Qualcomm or whomever else, any SoC vendor, to kind of invest their time, because it is substantial, to create BSPs for things which are for chips that are no longer selling or maybe no longer popular, whatever else, right? It has to be worth their dime. So let's say it was worth their dime, right? That they actually created a 5.x BSP. Then, the next party down the line, the device manufacturer. So in my example here, I'm using Samsung. So Samsung would have had to take a look at this and say, okay, are we still selling this phone? I mean, because yes, okay, the BSP's there, but if we're not selling this phone, why would we actually kind of do an update there? Okay, so if they are still selling this phone, or if it is one of their kind of like top kind of like earners, or kind of like one of the featured kind of like I don't want to use the brands themselves as an example, but you kind of like one of their big brands of phones, then they would say, okay, maybe we should do an upgrade, and then they do an upgrade, and then essentially then you have again the carrier here that has to roll this out to their users. All right. So for this to happen, you essentially had to have a certain alignment of the stars for an upgrade to make it back to you. Is Kotorola Forum MSN project related to the BSP? Yes. Okay. So it's not a Treble specific question, but the essentially usually if you're using a Qualcomm chipset, you will be directed to download stuff from Kotorola. So that's how upgrades would have happened. That's kind of like how that upgrade would have happened. Now let's fast forward to a year later, okay, October 2015, all right? Now you've got 6.x that has come out. Will this process repeat itself for that phone that you bought in early 2014? Then you have to ask questions. Is Qualcomm really still interested in that chip? It's 2 years down the road. Probably not. Maybe they moved on. Let's say they did. I'm just hypothetical here. Is Samsung still selling that device, or is it still something that they want to pour energies on? Maybe not. All right. And then is the network provider still interested in that? And the answer was probably also not. All right. So two versions down the road, we already see that this scenario is just not holding up. People are not going to probably upgrade to, or you're not going to get an upgrade for that device. So the intended release flow of Treble tries to solve or address the issues that I kind of just outlined. So the initial release doesn't change much, right? The initial rollout of say 8.x is practically the same thing. So we got 8.x comes out, you've got Qualcomm takes it, creates a BSP for it, Samsung creates an 8.x based device, Verizon rolls that out to the devices. This hasn't changed, okay? What has changed is how the internals now work. So the previous Android release is now essentially implemented, or essentially in this case 8.x, all right? 8.x is implemented over a defined vendor interface. And that vendor interface to the old vendor interface, and so the original vendor implementation now just works out of the box, okay? There seems to have been a glitch there on the live stream for a second. Sorry about that. So the idea here is that the enablement that was done by the various parties from Google to the consumer are still valid moving forward. Okay, what does that mean in terms of the changes to the internals of Android? So we still have the CTS, which is testing the framework, but now we have this vendor interface that is tested by VTS. All right. So whereas before we were just testing essentially the developer API, now we are testing also the vendor implementation and checking that that works exactly as prescribed so that the future frameworks can talk to it. So ideally what we want to get to is something like this. Google comes out with a new version of Android, it goes straight to the end user, all right? Essentially kind of short-circuiting the entire loop of other vendors, namely the SoC vendor, the device manufacturer, and also the network carrier who initially sold the device to the consumer. So, in theory, and obviously at this point it's just theory because there aren't enough versions that have come out. It will take a couple of years for us to kind of like really see what this looks like in real life. But in theory, 9.x comes out, users can use it right away, at least the ones that have a device that had a brand new 8.x on it. And then essentially 10x that comes out, and then users get it right away. Again, that's what we're trying to. That's what Treble is aiming for. So what does it take for this to happen? I mean, what does it take for this process, the simplified process, to actually take place? Well, first of all, Google must continue to support the old vendor interfaces. So in other words, this layer that they've defined here, however they define it for say 8.x, well, they're going to have to continue supporting that 8.x definition into 9, into 10, into whatever else is running afterward. Okay, that's really the core of it. All right. So in other words, as I just said, 8.x devices have got to have feature support, and and I'm just making this up. I don't even know the letters. They might change these in real life. And according to what I'm seeing and some of the presentations I've seen from some other folks, it seems that they're aiming for 4 to 5 releases, which is great. I mean, for consumers, that's going to be awesome. Now let's take a look at what this means underneath the framework in more detail. So again, same diagram that I've been using in the past, with the kernel native layer framework and applications. And we're not talking about the framework here in the previous presentation, in the previous slide, sorry, this Android OS framework. What's green, the green box here that you got, that's kind of like the middle of my diagram over here, all right? So what are the integration points? What are the points where the framework meets the hardware enablement? Let me see here. There's a question. What is the official interface Google will give us in order to move changes from the framework to, from the framework to the vendor partition in P, if any? Okay, so that's partly what I'm going to try to answer here in the rest of this presentation. So the integration points that we've got between the framework and the native layer are essentially kind of like, I'm trying to highlight them with these red circles here. So the libraries, okay, that's a hook point, all right? Any of the things that are up here are going to be using the libraries, and so are actually some other native things, including most importantly, the HAL modules. The HAL modules might actually be using some of this native library stuff. The HAL modules themselves, okay, that's an integration point. This essentially the system services, they know nothing about the hardware. All they know is they need to go get a hardware abstraction layer module of a certain type. And insofar as they find that, then they assume they can talk to the hardware. So in other words, essentially you've got here this as being a contract between the system services and the hardware. So that's another integration point. There are native daemons here. Some of them will need to be updated and such. There are some aspects here with the native tools, so Toybox and so on, and also the SE Linux rules, all right? And most importantly, or yet another important part here, is the Linux kernel itself. The kernel itself provides us with a surface that has not just configuration for it, but also a large number of APIs, the system calls, and so this has to be versioned as well. So all of these things are integration points that if we want to replace that top part and bolt another one on, we're going to have to standardize this bottom stuff in some way, shape, or form. So before Treble, the CTS, as I kind of mentioned, was testing just at this layer, all right? And if you had manufactured an Android device prior to that, and we've worked with a ton of people that have done this, you were free to go in here and change almost anything underneath this layer, and so long as it passed CTS, you were good to go. All right, there was nothing for you more to do than ensure that CTS was passing. If you look at what we have now, all right, the vendor test suite, all right, makes things a bit more complicated, because now we are actually going to test not just the CTS up here, but we're also going to test the hardware implementation that you've got down there. So that means libraries, the way they're used, the HALs, the native daemons, and some of the also the tools, SE Linux rules, and the kernel itself. And if you don't pass this, then you don't get certification from Google. And that means that, and I will come back to this later on when I talk about implications. What that means is that if you make any changes here, okay, first of all, sorry, if you make any changes at the bottom here, then you are likely not to pass a VTS, and that will essentially not make it possible for you to get certification. You can forego this if you aren't interested, obviously, in certification, but then the impact is the OTA aspect of essentially being able to change the framework and put a new one. That's going to be largely impacted. Of course, if you have to be certified, then it goes without a question that you have to pass VTS. But if you're not aiming for certification, then changing the bottom signatures here and essentially running VTS and failing at it won't preclude you from shipping, but it will preclude you from benefiting from the OTA infrastructure that's being put in place here, allowing you to essentially kind of change the framework with newer versions coming down the road. So what does Treble specifically add? What are we kind of adding to the stack in order to allow us to be able to kind of just switch frameworks? So there are some Linux kernel requirements, and some of this is a bit nitty-gritty. I might jump into Google's site later and show you some of this, but they have specific requirements as to how the kernel should be configured, and they also specify how things can be modified. The other thing, and this is kind of like one of the most important and complex aspects, is the hardware interface definition layer. So they've essentially defined a new format for the contract between the framework and the hardware enablement, and this is versioned, and essentially if you had worked in the HAL before, you probably had seen how difficult some of that work is. This has the difficulty has been ratcheted up quite significantly, and so tomorrow one of the things I will do is spend time on Heinel, because that one is a tough nut to crack. A lot of the other ones you can probably just read up on Google's site. Insofar as you kind of understand mentally where this fits in the map, it should be easy to kind of go through this, even though some of it is boring and tedious. So where do these things sit? So I've kind of jumped over VTS, and I've kind of played loosely here a bit with this stuff, just kind of like to illustrate you where those things fit. So VNTF, the vendor interface, essentially the vendor interface, which if you go back to my previous diagrams, is this red line here from the Google diagram, which is being tested by VTS. In other words, VTS here is coming to test this vendor interface. So the vendor interface here is sitting essentially on top of the kernel, on top of the Heinel, and we're trying to make sure that the Heinel interfaces are doing what Google thinks they should be doing, and also the kernel is matching the requirements that Google has laid out for it. The Heinel interface essentially is now somewhere in between the hardware abstraction layer and the system services. So in other words, if you had walked down the stack of a previous version of Android in between the application layer and the driver layer of the hardware, you had about 7 or 8 layers of software. We've added an additional one in the middle there called Heinel. And I guess logically speaking, in the flow of things in the future, that should be a replacement of the existing HAL layer, but for what it's worth, for now, people will see it as an additional layer. Then you've got the VNDK. So the VNDK essentially is a standardization of how libraries can be changed, or which can be replaced, where they should go to, and so on. And I'll dig into this one a bit separately later on. There is also, you'll notice, I'm not sure if this is clear, obviously from the camera angle, but maybe more on the actual screen live feed. The Heinel interface here also sits on top of some of the native command line tools, because some of them, like the networking configuration stuff, are pretty core to what Android does, and so therefore they also have to be kind of taken care of in a versioned fashion. So let's take a look at every one of those things. So like every one of those 5 things that we've got here. Let's take a closer look at those and see what that gives us. Okay, first of all, the Linux kernel. So Android, as I've presented before, and you can again refer to some older videos of mine on YouTube. Android depends a great deal on Linux. For now, and as far as I know, I haven't seen like Android running on any other OS. And even though in the early days they had contemplated using something like FreeBSD, today Android is very tightly tied to what the Linux kernel gives in terms of capabilities. So we need this. It's been around for a long time, all right? And essentially, the most important thing here is Google is downstream from the kernel developers, right? So if you look at it from the same release flow that I had before, in this case, Google is yet another party, and this is not a diagram Google came up with. This is kind of like my own cooking here. So essentially, I've added the Linux kernel here on the left just to kind of illustrate things within the context of what Google's trying to explain. So essentially, Google's yet another party in essentially this chain of delivery for a Linux kernel to actually reach users. So one of the common complaints, for example, in the open source community, is that a lot of the end user devices are using very ancient kernels. I mean, we still got devices there with 3.18 kernels, which are, by today's standards, at least in the Linux kernel world, ancient history. All right. So the trouble here is that if a new kernel version comes out and we want to find it on devices, then usually takes the Android team the time to add the Androidisms to it or customize it to whatever feature they have for Android these days, pass it on to the other parties, and then eventually gets to the user. And the trouble there as well is obviously when it comes time to fix security issues, this loop usually never actually happens. So the devices end up with kernels that have gaping security holes that are never actually solved. So this is another problem that Treble at least tries to initially address. It's not the entire solution, and I believe there are probably some other additional steps down the road that are going to be necessary, but it's a beginning, all right? So this is kind of like what I just mentioned. End-of-life kernel is very common, security issues, and while the kernel is invisible to the users, there are major implications for users, especially in terms of security. The other thing is that a lot of the kernel versions were inconsistent. And as far as my understanding goes, Google did not specify any requirements in terms of kernel versions prior to Treble. Vendors, be they the SoC vendors or the actual device manufacturer, were free to use whatever it is that they wanted to use in terms of kernel versions. And in real life, that's exactly what happened. We'd have Android versions running a wild range of kernel versions out there. So the idea with Treble and the kernel, at least, is to separate the deliverables that have to be done by every one of the parties in the chain. So in other words, okay, we know we got these people here involved. Can we make it such that whatever the silicon vendor adds, manufacturer adds, or the device manufacturer adds can be kind of like cut out or segmented in such a way that we can still have some kind of reference here. Now, there are aspects, as I mentioned, which are VTS enforced. And so some of the basic rules are essentially they're now going to require the use of LTS kernels. So if you're not familiar with the LTS, that's the Linux long-term support versions of the kernel. This is an effort that is independent of Google. Essentially, just Google is latching on to a community initiative. And the LTS kernels are meant to be maintained for about 2 years. That's the standard kind of time frame. They come out, and then Greg Hartman, who is the maintainer of the LTS versions, decides, okay, we're going to LTS this version, and then they maintain it essentially for about 2 years. Making sure bug fixes are fed back and security fixes are fed back, and so on and so forth. In addition to LTS, so they're spelling out a basic configuration of the kernel, they're spelling out the API that has to be available in the system calls, and as well as file systems and the file system features that have to be available in the kernel. And the interesting thing is they announced, I believe, what was it, Lenaro Connect last fall, that LTS version 4.4, and specifically 4.4, there was a bit of confusion at that point. People saying, hey, LTS is going 6 years now, and that's not what's happening. So it's not LTS of it in its entirety that's going to be supported for 6 years. Just 4.4 is going to be supported, I believe, until 2022 or something like that. So this gives essentially allowing essentially Android to be upgraded for 4 or 5 years on that version, which is very cool. And so these are the basic rules that have to be followed, and then essentially customization is still possible, and that's essentially going to be possible through configuration overrides, through loadable modules and device tree overlays. Obviously, these things are kind of a bit out of scope for this presentation, but they are ways to actually add or change the way a default configuration is provided. So the idea there is that the SoC vendor comes out with a standard release of their BSP for Android based on an LTS kernel, and then essentially the other parties down the stream will add their stuff using config overrides, loadable modules, and device tree overlays. And this is good stuff. I mean, the fact that they're structuring these things is good. It's still a bit unclear to me, and maybe just I haven't kind of read the proper documentation yet, but it's unclear to me how the actual upgrades are going to flow in the upgrade process. I think is just going to be doing this makes it easier to upgrade the kernel. Although changing frameworks is a bit easier than this. Okay, so in case you're like looking at this in the future, or you've got the slides in hand and you want to refer to what are the links that are relevant to this kernel stuff, I've just kind of put 2 links here. One of them is the general kernel documentation that Google has on source.android.com for the kernel stuff, and also LTS. So where's LTS? You go to kernel.org, and there are releases there, and LTS is one of them being described. Okay, so that's for the kernel and how Treble influences this. Now on to Heinel. First of all, let's look at essentially the HAL's role, the hardware abstraction layer's role. So again, going back to the architecture here, this is the box right here that if you've attended any of my previous presentations, I've kind of highlighted how this is important and how essentially that's the hardware enablement. So the system services, they use that to talk to hardware. Otherwise, they don't know how the hardware actually works other than through the HAL itself. So what is the role of the HAL? So we have a per-device hardware abstraction. So in other words, Google goes out and says, okay, I have a GPS device, and this GPS device for the system services to operate is going to have these functionalities and these callbacks, and these are the parameters being sent back and forth, and this is what we assume is going to come back in terms of return values and so on and so forth. So that's what the hardware abstraction layer is about. So for example, in the case of the Surface Flinger, it typically used Hardware Composer HAL. The location services used the GPS HAL. The lights service used the lights HAL, and so on. They might have added 1 or 2 HALs in every version if they supported INU kind of hardware. Now, Google specifies those, and essentially they're kind of like the official party that creates those contracts between the system services and the HAL implementations. Typically, the job of the manufacturer is to just implement whatever is described by Google. So Google says you need to have X, Y, and Z, manufacturer takes this and actually does the implementation, and that becomes the hardware enablement for that specific feature on that specific device. And if you were to look for reference implementation, say you wanted to see how to do a hardware composer HAL, GPS HAL, or lights HAL, you could either refer to the lead devices, there's a typo there, lead devices that are found in the AOSP that Google itself supports, or possibly some SoC vendor reference implementation or design found in the BSP. All right. Now the traditional HALs before 8.x. All right. So this is like 7x territory and before. Google would specify those things as C headers. So in other words, there was a hwcomposer.h, there was a lights.h, there was a GPS.h, and so on and so forth for every single type of hardware that was out there. A module author would take this header file and then create their implementation of it. All right. So if I was trying to implement lights, I would look at the lights HAL, possibly look at a reference implementation from the AOSP or some kind of BSP, and then I try to create my own for my hardware to control lights. Okay. At boot time, the framework would actually load those using the HAL infrastructure. Would say HW get module, gives it the module ID, and essentially retrieves this, and then that module was being used. All right. Now the issue is, of course, the headers could and did change across versions. So the signature, say for the hardware composer, the camera, whatever else you can think of, could possibly change across versions, and that required, because this is a C header, the person or team responsible for this to essentially rework their implementation, rebuild it, reship a new version. Okay, so it is quite involved. All right. So and to update a version of Android, it wasn't a matter of just updating one module, one HAL module. It required the manufacturer to ask their teams to update every single one of the modules. So if some of them were trivial, then that was great, but some of them could be fairly complicated, and then you actually had to go and massage every one of those things to work for the new version. All right. Now the Heinel layer that they've added, and as I said, I'm going to talk about this tomorrow in more detail. So Heinel stands for Hardware Interface Definition Language. As I showed you, it's a new layer between the system services and the HAL components, or the hardware support. And what really is important here, and I should have actually highlighted the entire line. First, it is a formalized and versioned HAL interface definition. All right. So in other words, we are going to say, okay, now with 8.x, the hardware composer or the graphics composer looks like this, and it has a version number tagged to it, and it becomes immutable. All right. So even though 9.x or whatever else comes out, the 8.x version, which has a corresponding version for the Heinel, is going to stay just the same. All right. So for example, for example, in 8.x, we got graphics composer is 2.1, GNSS, which is for the GPS, that is 1.0, and so on and so forth. Now, if you're familiar with AIDL, and if you've done any sort of app development, then maybe this is something that rings a bell. So AIDL files seem to be kind of like an inspiration for Heinel, because the Heinel files look like AIDL files, but I have to say that they just look like it, because there are some significant differences in certain details that I will cover tomorrow that make it such that you can't just use the AIDL tool on a Heinel file. It's a completely different world. Now, once a specific Heinel version has been published, all right, so for example, Graphics Composer 2.1 or GNSS 1.0, that signature will be the same in 9.x, at least the 2.1 one, okay, or the 1.0 one, and those will remain the same. And the idea is Google's implementation, all right, is supposed to continue supporting those old versions as they were, and therefore should not require a module author or vendor to come and have to rework that old implementation to work on 9.x. 9.x should just work on this older implementation as is. All right. Again, that's the theory. We're going to have to wait a few versions of Android to be able to kind of declare victory and say, oh yes, okay, this actually works. But that's the theory at this point in time. All right. So okay, a fresh port assumes you're using the latest version of the HALs. That's kind of implicit, at least from my point of view. As I said here, the most important thing is that once you create a enablement for, say, Hardware Composer 2.1, that should continue to work in all futures of versions of Android that continue to support Hardware Composer 2.1. All right. Eventually, you can assume that Google will eventually obsolete, this layer. But for now, the goal is to continue maintaining them. All right. So some people have, I've talked about this in other forums before, of course, and some people have told me, well, yes, but we're depending on Google, blah blah blah. But go back to the earlier part of this presentation and look at the incentives there, right? So Google has a very strong incentive to actually continue supporting this because that's what they want. They want to avoid, and let me kind of go back all the way to the beginning here. They want to avoid this, all right? This pie chart, multicolor pie chart showing that there's a zoo variety of versions in the market there. They want to get away from this and be closer to this to a certain extent. At least, again, that's my reading of the tea leaves. So we're getting too far. Okay, so that's for Heinel, and at this point, there's a lot more I can say about this, there is a lot of detail here and a lot of complexity added if you are already familiar with HALs. So tomorrow, if you are interested in this, tune into the presentation, and I'm going to dig into that. And as I said, I'm going to spend more time going around sources tomorrow than today, mostly being slides here. So some links to some documentation regarding Heinel. So the general documentation, all of this is on source.android.com. So you got an architecture side here, overall thing, then discussion about C++ implementations and Java implementations. And this is something that's kind of new. They now have the ability to provide essentially hardware enablement through Java code, and that's kind of interesting. All right. Moving on to the VNDK readability path. So historically, all right, anything could go under the hood. So again, going back to any of my architecture diagrams here, since we were just using CTS, all right, any vendor could tweak the bottom layers here to their heart's content. Insofar as the CTS passed, you could do anything you wanted. All right, that meant tweaking system services. It meant tweaking HAL signatures. Whatever it is that worked for you, it would work. I mean, insofar as CTS passed. And in fact, that's exactly what happened. All right, and so this could sometimes be taken to extremes, as I mentioned here, and place yourself in the shoes of any major manufacturer. You're launching one of a key device. Some of the trade press are going to be looking at this very closely, seeing what it is that you are pushing out, probably running benchmarks, and so on and so forth. So you're obviously going to want to have very good reviews of your device. And so essentially, what are you going to do? Well, you're going to try to tweak the performance here and the battery for everything. Libraries, the core components of the framework, anything that you can think of that can ensure that when this device comes out, it gets good reviews, then you are probably going to do, okay? So what this resulted in is there were sometimes significant differences between essentially the whatever came out with the AOSP and what actually shipped in actual devices. So that's a problem, of course, especially if you're trying to do some kind of upgrades. All right, I'm seeing here that possibly the signal for the live stream is not as good. If there are any substantial breaks here in the stream, just let me know here, and I will try to see if there's something that needs to be fixed. Okay, so what does the VNDK do? All right, the VNDK essentially provides a predefined way to mitigate the differences between the Google minted libraries and whatever the vendor wants to do. All right, and there is quite a few concepts that are being added and to make this possible. And if you're interested in this, or you have to manage this, then I really would kind of refer you back to the documentation. It's a bit boring to go through it, and it's very dry. So just go look at the material. They do kind of detail what it means and what it implies for you as a vendor. So it is a good point to start. And honestly, what you'll want to do is make sure that you've got somebody who's responsible for this in your team. If you've got a large team who is participating in creating devices, then try to see, if you can have somebody kind of own this in some way, shape, or form. All right, and this is kind of like an area where Google is trying to, walk a tightrope. So essentially, what they're trying to do here is make sure upgradability is possible, but there is a will to try to allow manufacturers to customize things to a certain degree insofar as it's manageable. So there's an equilibrium here that'll have to be reached. We'll see what that really means moving forward. And so the documentation here, you can go again source.android.com. In this case, there's a VNDK link that you can get more information about that. Okay, the VNTF, the vendor interface. All right, so the idea here. Okay, so actually, let me go back to the diagram here. This one. All right, so the vendor interface, as I said, sits between the framework and the actual vendor enablement, whatever it is, or whatever form it takes. So when I'm going to want to do an OTA, all right, I'm going to try to want to bolt another green box here onto the old vendor implementation. And there's going to be a need for some kind of handshake between the vendor implementation, or essentially the framework, running on the device as it is presently, and the incoming framework, so that they can see if they match together. Does the new framework have the properly required Heinels from the old vendor implementation, or does the incoming framework have what the device expects from the framework to have in order to be able to actually run on the device? And so that's what the VNTF thing is for. So going back to here. So that's the handshake part. We have to be able to kind of like match things together. Namely, we want to make sure the Heinel versions are good, the kernel specifics, features and such are good, the policies work together, the Android verified boot, and so on and so forth. And so this is essentially how they explain the VNTF on their source.android.com website. So essentially, you've got the device on one hand and the incoming framework essentially on the other hand. And so the device has a manifest and incompatibility matrix, and the same thing on the other side, the framework has a manifest and a compatibility matrix. And so the compatibility matrix of the framework tests the manifest that's provided by the device, and the framework manifest, the device tests the manifest provided by the framework. And insofar as those things match, then we can have a successful OTA. And so you kind of like try to go down the questions here. So what's the device manifest do? What does the framework manifest do? The compatibility matrix, and so on and so forth. And so essentially, Google specifies the manifest format, okay? The compatibility matrices, how they work, and the matching rules between the two. They're still using this word manifest, so now there's like a third meaning of the word manifest in Android. The other one's being the Android application manifest, and the other one, the second one being the repo manifest. But this is a VNTF manifest, so third kind of variant of manifest, and completely unrelated. Those three things are being totally unrelated from one another. So this too is something that you have to have a solid understanding of, and again, it can be a bit tedious to go through, and this also is something that you probably want to have somebody in your team be responsible for. All right, obviously if you're interested in OTAs. If you're not, then kind of different story here, but that's probably something that you want to have a look at. And again, a reference link for that. Finally, VTS. So VTS is kind of like the thing that makes sure that everything we talked about here actually works as prescribed and ensures that moving forward upgrades are actually possible. So what does it do? Much like the VCTS, it has a number of test categories. So testing the Heinel, the kernel, there's some kernel tests itself, testing the VNDK, making sure that that conforms to what they spelled out, performance, and so on and so forth. And now this is required for certification like CTS, right? So keep this in mind, all right? If you are looking for any sort of certification, you will want to dedicate resources to this as well. Obviously, we're still young in the life of Treble and VTS, but it's probably a safe bet to say that if you've already got, say, a checklist of things for CTS, then you should have an equivalent checklist of things for VTS as well. And again, like before, the main documentation link. Interestingly, there's an additional link here that is not on source.android.com, but rather in the actual sources of Android. And you can get this from android.googlesource.com. The link is here on the slide. There's a user manual and some additional stuff in here as well. Okay. What does all that we've covered here kind of have as an implication if you are creating custom devices? So essentially, the surface of things that you could customize if you want Google Mobile certification has shrunk significantly here, and you know, some of the things that are listed here are kind of no-go anymore. So for example, if you're tweaking system services, tweaking HAL signatures, replacing core libraries, or anything of that kind, that's right now a bit more difficult, if not impossible, to carry out. All right. Even the changes that are permitted, you know, like tweaking libraries and are a bit more complicated, because now if you can tweak libraries, but you have to conform to VNDK. You can't change existing system services, but you can add your own, and then they're, you know, going into the list of vendor system services. So they've codified a lot of things that were essentially Wild West in the past. It's a bit more formal here. Okay. Oh, I just noticed a question from on the other chat here. So, will 4.4 LTS have backports fixes for Spectre and Meltdown? I don't know the answer to that. I'll have to check for this. I'm not. I'll have to ask actually. I don't know whether that's the case or not. I would presume so, but it's really kind of like, you know, just a presumption on my part based on, you know, the information that I have in my mind. Okay, so. The benefit here to adhere to vanilla, even if you're not aiming for VTS, GMS certification, is essentially simplified OTA. All right, and I mean, a lot of the customers that we've worked with, I think, would appreciate this because essentially, most of the customized devices that have been put out there have had a rough time being updated. I mean, it's a significant thing to actually get Android working. It's a completely different one to actually upgrade it because, you know, it's almost, at least in the past, it was almost a new port. Okay, sorry, I missed a few part. How does Treble achieve kernel security patch? I'm not entirely sure I understand the question here, but I guess just to go back to the kernel aspect, essentially what Google has done is they specified a few ground rules for what has to be found in the kernels that are to be certified, and the aim is for those ground rules to simplify the upgrade process of the kernels. And so notice also that in my entire discussion here, I'm not actually going into the specifics of the OTA and what that will mean. I am going to hold out on that to see how that actually works out in the future. You know, aside from whatever they have in OTA mechanisms today, I want to see, you know, actual rollouts and see in real life how this actually takes place. With say P and Q and whatever else comes afterwards. Okay, so if you don't actually care about GMS, obviously everything that you were able to tweak before, you can still tweak. I mean, there's nothing closing this off from you. The price you're paying though is reduced OTA capability. All right. One thing or a few things here to be said about not just the work that you're doing, but the work that you're getting from others and the interfacing that you're doing with others. So you will need to take a closer look at what you get from SoC vendors and any sort of outsourcing party that you're working with to make sure that whatever they're giving you is Treble conformant or, you know, falls within the lines of what the documentation Google says the new versions should be doing. Because if you don't, I mean, if you get a, you know, a bad port or port that has some, you know, quick fixes here and there, you might be in a situation where yes, you got 8.x running, but you can't get certified. So make sure that whomever you're working with knows what they're doing. Obviously, the assumption is most of the major SoC vendors should be able to give you BSPs that do the job properly, but you have to understand that this is a significantly complex change. There's significantly complex changes being made to Android, and I assume that not only Google is going to have to learn how to manage the ecosystem there they have with those new changes, but also everybody downstream. So the SoC vendor is going to have to learn to live with Treble. The hardware manufacturer is going to have to live with Treble. So if you get an eval board, you want to check what you're getting, making sure that it actually works as it should be. So yeah, as I said, the incentive is there for the SoC vendors. The downstream board manufacturers may not have the know-how or may try to take shortcuts. So those are probably the areas where you have to check a bit more. Okay. Okay. So kind of like a bit of closing recommendations here. So it'll probably take several years before we actually see the effects and the benefits of Treble. We'll see how that goes. I mean, I'm very hopeful. I think just as a user, I'm very happy to see this happen. That means my devices are going to have a bit more life to them. And I'm happy to buy new devices, but at the same time, I want to make sure that my device has some kind of upgrade path, if nothing else, just in terms of security. Okay, just another question here. Seems like even if you don't intend to get GMS certified, O introduces a pretty heavy SE policy to enforce it. Would we essentially have to put the gut the existing policies? I'm not sure I understand the question entirely here. I mean, is that with regards to customized policies that you might have? Or is it the existing policies found in Android itself? So I'll just give a minute here for the person to try to answer the question that I sent, and I'll come back to the question. I'll continue this for a second here. So, all right. So, as I said, they've established some solid ground, and they are going to likely have to learn a bit how this works for them and for the ecosystem. And I believe anybody who has to work inside the guts of Android is going to have to learn to live with Treble. All right. So kind of like this is kind of like copy and pasted almost from the blog post that I was referring to earlier. And let me just go back to the question here that had been asked. So are we going to have to gut the existing policies in Android? So generally speaking, with the SE Linux policies, I tend to recommend that people stick with what Google has, because managing those rules is really hard. For having attacked or having not been attacked, but having to have to attack some problems that I faced with SE rules in the past with Android, I would probably say that you want to stick with what essentially Google gives you, and just tweak it as is. I wouldn't go ahead and kind of gut the entire thing. Okay, dumb question. Post-Treble OTA update won't update a boot image, so how does kernel security updates will be pushed? Okay, so that's the part where I would prefer not to speak too much of, as I want to see what those actual OTAs will look like in the future. And at least the first time I looked at the the documentation they had on their website, I can't remember seeing too much about that, although I might have skipped it. And if you're listening to this and you've seen the doc, I'd love to have the pointer for this if you have the information. Otherwise, I want to see what's going to happen in the wild once they come out with actual OTAs that are going to apply on older vendor implementations. So just kind of reading these a bit, so make sure you've got a firm understanding of what Treble does. Make sure your teams understand what this means for their work, and obviously try to seek information for this if they don't have the requisite information. If certification is on the agenda, obviously you need to be very careful about what you're going to be planning here in terms of tests and workflow internally. And then, as I just kind of mentioned a minute ago, in selecting partners and SoC vendors, make sure that they understand what it is that it means to work with Treble in real life, because you're going to essentially require them to do the proper job for you to eventually get certified, if that's what you're looking for, or if nothing else. If you aim for those devices to be OTA-able, then you're going to need those parties that you're interfacing with to do a proper job so that their part can actually be part of that coming OTA. And so that's pretty much it, what I had for this in terms of content. And I'm going to stick around here for a minute or two, see if anybody has a question either over the YouTube chat or some of the other channels that I had opened up for people to participate in. And if you decide to sign off early, then again, be sure to tune in tomorrow. I will take the time to actually go through Heinel and essentially provide more detail about what that means, what that changes, and that presentation is going to be more source code heavy than the present one. Okay, how does Treble come in play when you extend the Android framework, for e.g. when you create a new service and a new HAL for it? Okay, that's an excellent question. So essentially, the infrastructure they've added, say for Heinel, you can use that for a new system service that you add. I mean, perfectly doable, probably to a certain extent advisable. You could benefit from this yourself because they've, as I said, versioned those definitions. So in other words, for OTAing your own device, then having those versions is certainly going to be helpful. But you don't, obviously, if you're adding your own system service as a separate, say, APK encompassed in a separate APK with a persistent flag to on or whatever, you're free to discount. You were free to discount HALs in the past anyway. You're free to discount those, moving forward as well. But certainly, if you want to do it in a clean fashion, in a fashion that follows the spirit of what they're doing, and a fashion that will allow you to benefit from the fact that they've defined those things properly to allow you to OTA, then certainly following the Heinel stuff can be useful. And the infrastructure in there is usable. It's not like exclusive to their stuff. What you can't do though is be able to kind of like walk into their Heinel definitions and change them. Those are canonical. I mean, they come out with them. That's what, say, HW Composer version X looks like, and it will forever look like that. All right. Any additional questions? All right. How does it make sense for OEM, which does modification system layer? Is that really worth to put the effort to implement Treble for such a use case? Is it worth the effort to actually do it in a essentially in the same way that Google does it? That really depends on the actual case at hand. If it is a product that is to have, first, if it's a product that involves a large number of people and it is probably going to be upgraded a few versions, then using the Heinel stuff it can be to your benefit, again, for the OTA purposes. Again, I mean, it's a technical choice where you can say, I'm going to forego Heinels altogether. I'm just going to publish a system service. Here's the API for the system service. You talk to the system service. How it talks to the hardware is none of anybody's business. But that's a choice that has to be made. All right. Gonna wait a minute or two again, in case some questions pop up. All right, we might be having a question here on the other side. Just give me 1 second. Oh, here's one more. Have the Spectrum available and oh yeah, so okay, that's the same question we had earlier. So regarding the Spectrum Meltdown backports to 4.4, I'll have to re-advise. Oh, here's another one. Will there be a release of embedded Android version 2? Okay, all I'm going to say publicly about this is I'm working on it. I don't want to promise any timelines here. Books are unwieldy beasts, and their delivery is non-deterministic. So I will hold off on an actual release date until the release is actually made, but it's certainly on my list. All right. So with all that being said, since I'm not having any more questions on the private side of things, and here's another one. Yeah. So okay. So since we kind of seem to have exhausted at least the major questions, I will probably sign off and sign up again tomorrow at the same tomorrow at the same time. Do we have Treble on P will look like? Do we know what Treble on P will look like? Unfortunately not. We're gonna have to wait for P to come out to see what that looks like. I anticipate if I use, kind of like historically what they've done, say for example when they introduced the SE rules and some other core things they've added, there are likely going to be some tweaks to how this works. I'm looking forward to that. See what tweaks they thought were necessary to make things happen. All right. Okay, thanks everyone for attending. And again, if you're watching this at some point in the future, or if during the presentation you saw any mistakes, please by all means let me know, and I'm happy to correct things after the fact. All right, see you guys tomorrow. We'll talk about Heinel in more detail.